Good afternoon. I'd like to talk a little bit about mapping water in the desert. And I know that kind of seems like an oxymoron. I work for the Southern Nevada Water Authority, which is a non-for-profit, quasi-government agency that is the water provider for all of Southern Nevada. Our division of mapping and analysis, we support all of the departments in our organization. We support state agencies as well as some federal agencies as far as water resources and use go. This is basically the area that we cover, and our member agencies or our purveyors, we provide the water to our purveyors who then provide it to the customers. When most people think about Las Vegas and the Southern Nevada, this is what usually comes to mind. When I tell people that I work doing GIS and mapping in the desert, they kind of wonder, well, what exactly are you doing? Because it's a desert and there's no water. So what exactly are you mapping? And, you know, I've had a couple of people ask, well, do you make maps of how to get to the Mandalay Bay swimming pool? Or what time the schedule for the Bellagio fountains? But really, this is more the reality of Southern Nevada. Water scarcity is a big thing in this desert, but mapping in the desert is not really anything new. These are maps from the 1870s from John Wesley Powell and his survey of the Colorado River. And this has been going on a long time, and this provides the basis, even today, of water availability in the Southwest. In 1922, the lower Colorado River allotment was determined by the Colorado River Compact. And this is often described as the law of the river, is how it's referred to, even in legal documents. As you can see, Nevada did not get a very large portion of this allotment. 4% of the total flow in the southern part of the Colorado Basin was allotted to Nevada. Now this is, as we can see, this causes a significant issue because this is the areas where water was provided and used in 1950 in the Las Vegas Valley compared to last year, the areas that are provided to. The allotment or the amount of water hasn't changed at all. And this creates an issue. In our organization, the cartography part of it plays a vital role in nearly everything we do. It's important for procurement of water sources, the usage, and everything else. And I'm gonna outline some of those things and some of those cartographic products that we've looked at. The first thing is water resources. Nearly all of the water Nevada and Southern Nevada and Las Vegas use comes from the Colorado River, which is stored in the largest reservoir in the United States in Lake Mead. There's also tributary resources and groundwater resources from aquifers. So in order to get a good idea, we really need to understand the Colorado River Basin. And these are some products that were created to really understand the components, the functions, and really how that water gets to a place where we can distribute that to our purveyors. So a lot of effort is going into really keeping track of infrastructure, supply, and other types of things. And as part of that, this is a map that was done for a project that is funded by almost all of the upper Colorado Basin states, which we contribute to. And these are actually cloud seeding generator sites in the upper basin. And this is to help additional snowpack and precipitation in these upper areas. And even though it doesn't create a big difference, it does create a little difference, which is really important to really the supply and real demand that's needed from a lot of the lower basin states. Pretty much all of the water, really the majority of the water, comes from the upper basin in the form of snowpack. There's very little that has ever contributed to southern Nevada that isn't from snowmelt in the upper basin. So that's a critical component, and that's why we fund these projects to help increase snowpack as much as possible. Another component is tributary and supplemental flows, and this is of the Virgin and River flow system, which originates around Zion National Park in southern Utah. And this actually flows down and contributes to Lake Mead. And so we do keep track of flows on the river, and we do have concerns about anything that's happening upstream as far as affecting any of those flows. We're also concerned about any of the basins and the hydrographic areas, and we pretty much do this for almost all the basins. There's a pretty in-depth study by the hydrologists and geologists as far as determining how the basins function, how the subsurface flows are, what springs are present in that basin, and any other characteristic that may aid in helping monitor those type of things. While there's not a lot of surface water in southern Nevada other than the Virgin River, there are programs that are put in place. One of them is called the Intentionally Created Surplus, and I'll get into that in just a minute, but we also monitor flow measurements and health and environmental stewardship, and the cartography component of that is always present in any kind of report or any kind of presentation done on this. This is an area just north of Las Vegas on the Virgin and Muddy Rivers. The areas in orange right there are actually agricultural type areas, and at the Southern Nevada Water Authority, we helped implement a program called Tributary Conservation Intentionally Created Surplus. And what that means is there are areas there where they divert water out of the river into agricultural areas. And what the Water Authority has done is they've partnered with the irrigation companies that procure those water rights to help irrigate areas. And we buy shares in the irrigation company. And with those shares, we intentionally fallow areas that normally would have been planted with agricultural areas. And that water that was normally used to irrigate is now kept in this river system and returned into Lake Mead. And this is done in conjunction with the Nevada State Engineer and the Bureau of Reclamation. The Bureau of Reclamation is the ones that signs off. So in order for us to do this and for them to accept this, we have to map and keep track of what areas are irrigated and what areas aren't. We use color infrared, we use NDVI values to identify those areas, calculate acreage, and present what type of crop type they are in order to calculate evapotranspiration on those as additional water loss through it. And then our reports are submitted to the Bureau of Reclamation. And once those are accepted, we can then take credit for that water in Lake Mead as a resource. So it's supplemental to our Colorado water rights. This is just another example of us trying to use the NDVI values and calculate what areas are irrigated and which areas aren't. Additionally, Nevada has lots of what they're called vested water rights that were put in place before the Colorado River Compact was established. Now, because those were put in place before, they override any new type of water right. And so they're very, very intense. And this came across that we need to understand where those original water rights were and what areas they covered and how they functioned. And so this came across a while back, and it's a hand-drawn map that was done in 1918 showing the water rights, and we've rectified it, georeferenced it, and used that as a reference for what the initial water right was and actually how the water was used. And it's pretty amazing. It matches up really accurately, being a hand-drawn, hand-surveyed type thing, to what a lot of the fields are today in the river channel even. We also help support planning and operations. We actually have a separate group from ours that actually works internally on proprietary applications for the actual operations and SCADA system. But they don't really do any mapping per se. They just maintain that part of it. Here we're looking at recharge, annual recharge for the mountains in the area, and then on the right is basin fill characteristics. And the reason this is important is there are a lot of wells within the valley, and sometimes those wells need to be replaced, and so they need to know what the optimal place is to drill and to be able to extract some of the subsurface water is. The one on the left is just part of the SCADA systems, and we do provide input to them as far as their internal application go. They have nearly 150 layers in this thing, and they've reached kind of a critical mass on symbology when they're trying to display things. So we try to help them out with different layer symbology ideas. The one on the right is part of one of the irrigation systems, and at a moment when the reservoir that was feeding this one area in Moapa Valley was dry, it gave us opportunity to go in and resurvey the area. And what we found was there's a lot really high, you can see kind of by the heat map, there's really high sediment buildup on the outflow of that reservoir, which really changed the holding capacity of the reservoir, and no one really knew what really that was at the time until we did this analysis and mapped that out. There's a lot of monitoring that goes on in the valley, and these are all wells in the valley, and we partner with the Nevada Department of Water Resources to monitor these and to help close it. And the reason is a lot of these are old, abandoned wells or unknown wells that can cause problems with contamination and contaminating groundwater that's existing. And so we have a project in place where all these are mapped, all these are monitored, and we try to get them plugged and abandoned if they're not used. And the state, we help the state monitor these and provide information and maps for locations and status. The one on the left, we also monitor wells that are active and the pumpage and what type of yield is coming out of them, as well as pressure zones. We also monitor the map on the right is per perchlorate amounts, and this is right around the Las Vegas airport. And the initial thought was that the perchlorate concentrations were high because of the density of septic tanks in the area, and those are the gray shaded areas. But they found that really the airport itself was the one contributing the most to those measurements. This one also came up that there's always been known that there's been a big area, 3 big areas of subsidence in Las Vegas Alley, and they've known this for a long, long time. You can go out to some areas and the difference, and it shows on here, the difference is almost 5 feet in some areas. And it'll go up and down depending on how much runoff or how much recharge is happening from the mountain ranges. But one of our hydrologists also came up with the idea, and he wanted our production wells put on top of here. And I don't think anybody realized what impact the production wells were having on these subsidence areas. They're all, just right next to the real areas. Lake Mead, Lake Mead is also an important area since all of our water is drawn out of Lake Mead through intakes. Water quality samples are taken weekly, or sometimes daily in some areas, weekly in other areas, to make sure water quality remains. And water conservation is a huge issue right now. There's a hex cell map we did showing areas where turf conversions are targeted, and what they want is they want people removing grass because it's a big water usage that doesn't return to the system. They've deemed an assembly bill in the Nevada legislature that they need to remove what's considered non-functional turf, which is turf that has no recreational or real usage other than, just aesthetics. And so a lot of the grass areas in front of HOAs and things like that are now, they're deemed to be all removed. And it's a law now that they have to take out those areas. We've done a lot of mapping on analysis of turf areas and grass and what's in residential and non-residential areas. And this is in Henderson, showing targeting a bunch of those areas. There's also such an environmental considerations that we do map. There's restoration of old historical vegetative areas that we're involved in helping replant and revegetate. And then there's this little guy. He's an endangered species that's on one of the rivers in one of our properties. And since he's on our property, we have to do a lot of analysis and mapping on as far as habitat. And this is just a stream channel. It also incorporates subsurface substrate and things like that. And this is one of the last maps I did. And since these small fish thrive in certain areas, these are hot spring areas that feed the Muddy River. This was done to help identify habitat areas and optimize those. And I thank you for coming today. This is actually the current condition of Boulder Bay, where there used to be a boat launch, but now you have to go a mile to hit the water. So.